So up to this point, we still haven't done any tests. We've just done some sort of visual checks to make sure that it looks like the circuit's been designed properly. So the protected devices, breaking capacity is more than the fault current. We've got to check that the cable is capable of, it's big enough to carry the design current of the circuit. We've got to check the cable size against the size of the breaker that's been used. So 1.5 millimeter squared cable. If we have a look in this book, the on-site guide, there we go. So even if that cable is running a stud wall with insulation, it's still capable of carrying 10 amps. So the fact that it's protected by a 6 amp breaker is okay. So the cable can carry more current than the breaker, so the breaker will trip and the cable won't overheat. So they're all sort of, you know, preliminary checks really to make sure that the circuit's been designed okay. We then start taking some measurements. There's a few different tests that we do. The first one is the R1+R2 test. So to explain this bit, let's just have a quick look at a picture. So there are two measurements that we take. Like I said, R1, R2. So everything on the right hand side of this picture is what goes on inside your house, and everything on the left is the responsibility of the network operator. Now what we're looking at here is what's called the earth fault loop path. So current flows in the line conductor. This load might be a light switch, a socket outlet, it might be an oven, a shower, whatever. Now, under normal operating conditions, current flows to the load in the brown line conductor, and then it flows back to the consumer unit and actually out to the transformer in the street down the neutral blue conductor. Now, if there's any sort of fault to, for argument's sake, the casing of your oven, the metal casing, then that's where the third conductor in the cable comes into play, the earth, or the CPC, the circuit protected conductor. Most people just call it earth. Current will flow down there instead. And so what we do is we measure the resistance in your house on every individual circuit. We measure the resistance of the live all the way to the current using piece of equipment, and then back down the earth to the consumer unit. That's what's called the R1+R2 measurement. We then add that on to a resistance measurement that we take of everything that happens at the supply side of your installation. We add those two values together, and that gives us what's called a ZS value, the resistance of the entire earth fault loop path. Now that needs to be below a certain value for the ADS, for the automatic disconnection of supply, to happen in the right amount of time, 0.4 seconds or 5 seconds. So let's just have a quick look at, for argument's sake, let's have a look at a 6 amp MCB.